everybody hear me all right? Hello? Yeah, sorry, we're already pretty far behind, so no real break time in between the sessions. We'll just dive right in. If you do need to be somewhere at the 12 o'clock, just, do whatever you got to do. Don't worry about it. So I'm Andrew Jones, Drew Jones. I call myself Drew. This is Eric. And we both work for Red Hat. And today we want to present to you some of the stuff we've been doing at Red Hat for enabling virtualization on ARM servers. Yay! Okay, so we also have a not-so-secret goal in order to try to motivate those that are using ARM servers or developing for ARM and working on virtualization in particular to start using some of the stack that we see as an important piece. Most in particular, libvirt. We'll have some, Eric will try to introduce libvirt in the short amount of time we have, as well as demonstrate it with a few examples in order to try to give that motivation. Additionally, in any time we have remaining, we want to present some of the things we do with respect to building a verification test suite so we can test all of that virt stack. Now we on our virt team specifically work on the three lowest levels of the virt stack. So that means kvm, QEMU, and libvirt. That doesn't mean that we're not interested in all the upper levels. And in fact, that's why we are so big advocates of libvirt. We believe that that enables those upper levels much better. Now, also in order to motivate those that are maybe libvirt skeptics, we want to demonstrate how the complexity of QEMU can grow when we try to use it for what we believe an enterprise guest needs to have in order to be sufficient for enterprise use cases. And so that's how I want to start the presentation. I want to describe our vision of an enterprise guest, basically list a bunch of features and requirements that we are trying to make sure the guest can fulfill. That'll lead into one slide where I show some QEMU complexity, at which point I'll turn the microphone over to Eric, where he'll take over and talk about libvirt. As I said, with some examples. I'll take the microphone back for the verification part, and then we'll go to lunch. Okay. So, an enterprise guest has two sets of requirements. It has the requirements that also overlap those of the physical host. And an enterprise host will come in large range of sizes, but generally big. And we've seen in the x86 world, at least, that the guest also needs to be able to support large sizes. We've seen guests with as much as a terabyte of memory. We've seen them with hundreds of vCPUs. So we want to make sure that our guest also scales like a host does. Sorry, that also means I/O. So lots of disks, lots of network adapters. With respect to I/O, the devices should be discoverable like they would be on a physical machine. That means through PCIe, host bridge, topology. The guest admin should be able to manage their own kernel. So that means that they should have a firmware in the guest that allows them to do that. And all the above, all those different things should all follow the standards. And anyone that was here previous hour or two ago, that was just discussed. Now, the guest doesn't necessarily need to hit all those. I actually can't say I know if our guest does at this time. It would be nice if it could hit all the ones possible. Now, the other set of requirements and features that we have for a guest are naturally the ones that a virtual machine would have. And so, because virtual machines they have one degree of separation from the hardware already. In order to allow for more performant I/O, we use virt I/O, which is par virt. So we need to support that. we also have the advantage of being able to use any kind of device we want, really, because when we're not using VirtIO and we use an emulated device, it's just software, so we can decide what we want. And in that case, we generally want to choose the most generic, which gives us the widest range of deployment. There's no reason to pick a very specific device to emulate and then deploy it, and you find it only works on one hypervisor. Finally, there's also a VM-spec written by Lenaro, which we try to conform to as well. So this both describes what hypervisors should try to offer a guest and what a guest image should provide support for. So it can, like I said, was the generic devices. For example, PL011 is one of the devices that a guest can expect, and this allows it to know that it's going to have a UART that it can use. Okay, this is a kind of laundry list of features. The kitchen sink is, you know, everything but the kitchen sink thingy joke. I won't go into detail on all of these because we don't have time during this talk. We're trying to cover things in a broad way. I would say that all of these features are things we find necessary, and I would like to talk to anyone about them during the rest of the week that wants to talk about them. As far as my not-so-secret goal to motivate libvirt use by expressing that QEMU can become quite complex when you use, when you extend features, probably the only ones up there that would actually help support that argument are the fact that with PCIe topology, the command line can blow up. Also with virtual NUMA, when you try to add all the node descriptions and mappings of vCPUs to virtual NUMA nodes, the QEMU command line definitely blows up. The rest of them maybe are not so painful. Okay, so this is my one slide QEMU complexity motivator slide.
It's not that bad.
It's specifically selected that it'll fit there. we could have made another one, 2 slides more. So.
Well, there's actually things you cannot do, like pinning CPUs, because you can't know where the things run and which thread numbers and stuff, that you simply cannot do with the command line. So you have an even better argument.
Yes, and yeah, that is actually an argument that Eric will bring up when he goes into his libvirt stuff, but thank you. So I kind of have these bullets in reverse order because first I wanted to show you the most obvious complexity, the QEMU command line that everybody knows. Then I wanted to point out that for managing these guests without an additional layer like libvirt, then you would do so with QMP, which also has like 140 some commands and also a big pile of parameters. So, and it's not all that easy to use. You need to set up a socket and be able to interface with it. Finally, all of that stuff is a moving target. So as QEMU grows, new features and everything, it will actually add new interfaces, of course. So to teach all upper level stacks, like I talked about earlier, OpenStack, etc., the QEMU interfaces and command line can be daunting. Okay, so this is where I want to turn it over. Thanks, Eric.
Okay, thank you. Okay, so let's try to introduce libvirt first. So libvirt is a set of software components that include an API and its library, a daemon, and a C language, a command language tool, which is named virch, that allows to interact with the libvirt implementation. So what is interesting is that you can run libvirt directly on the remote machine, the one that runs virtualization, or you can use libvirt remotely on your laptop typically and interact remotely with your remote nodes. So what is interesting is that libvirt was devised to manage guests and also offers many services related to the host, the physical host, typically enables to manage network interfaces or storage. It was devised for that purpose and is typically adapted to manage enterprise guests. The implementation is usable by many different languages like C, Python, or Java. And this is the entry point for famous middlewares like OpenStack or Auger, and this is why we focus today on this level, because it brings many advantages to test at this level. And also, the advantage is that you have a full ecosystem of utilities that plug onto libvirt. And so I quote some of them. You have a graphical user interface, which is a virt manager. Virt install allows you to provision guests, while the media can be local to your machine or remotely. You can fetch it remotely through various transport protocols. And you have also libguestfs library and the associated utility, guestfish, which allows you to access the virtual machine file system and modifies it. And so you have a comprehensive list of all the middlewares and utilities that are supported. So a great advantage of libvirt is that it is portable and it supports a great variety of hypervisors. So among them, of course, KVM, but Xen, containers, and so on. So it's really portable for users.
One sec. This libhuge.fs, so it's a new introduced file system with the Blitz.
Sorry, can you repeat?
Libhuge.fs.
libguestfs?
And yeah.
No, I think it exists for a while now, and it.
What's the specialty about that?
What? So.
What's the specialty about that?
What exactly it does.
So it allows you to access the virtual machine file system and modify it. So basically.
It's quite useful for manipulating images. So if you don't want to install an entire guest in order to log into it and manipulate it the normal admin way, you can actually just take an image, a guest image, which would be like a QCOW2, for example, and with libguestfs you can modify it, change some of the etsy configs, whatever you want to do with it, quite a bit easier, faster.
For crashes, right? You want to go and analyze what happened afterwards. You don't want to deal with the complexity of finding multiple files and images and going through that yourself.
Thank you.
Okay, so now let's have a look at the latest features that are available in libvirt 3 major release. So first of all, we have virt.io PCI, which is used by default. Before it was virt.io MMIO. So now the benefits is that you can get access to, you can instantiate much more virt.io devices. It has better performance over virt.io MMIO. And typically you can get access to full feature vhost net capability. And along with this by default virt.io PCI usage, we have now a PCIe placement that is identical to what is done on x86, and I will describe this later on. As described by Alex yesterday during his session, so we now have the support for video cards through virt.io GPU, and not virt.io VGA. And we have also now support of so the capability to have automatic detection for the gig version and to be able to force a given to opt-in for a given gig version. So those were features that required some additional code in libvirt. So now we get access to new features simply because some dependencies were resolved on kernel side or on QEMU side, and this just works fine, as we we will show you just after. So among those features, we have PMU enablement, we have PCI Device Assignment, and we have an enhanced migration capability, typically for GigV3 and ITS. So let's start first by one of the main features that was introduced lately. So this is PCI placement. So we made the decision to implement PCI Express only hierarchy, so no legacy PCI. So the PCI placement fully complies with documentation. So documentation that was introduced in QEMU 3. This was developed by Marcel Appelbaum and largely reviewed on the QEMU mailing list. So the principle is that we instantiate PCIe root ports at the top of the hierarchy. So for the time being, those are some Intel's IOH root ports, but this is going to change because Marcel developed also a generic root port. So using the multifunction capability of the PCI device, we are able to instantiate up to 256 root ports. So it gives space for adding PCIe devices. So flat hierarchy is preferred, but if you want to, you have the capability to add switches, or you can add, you can add switches, but you must be aware that libvirt will not do that for you. You will need to do that on purpose. Okay, and what is very important is that thanks to this PCI topology, you can hot-plug and hot-unplug devices freely, as long as you have unused PCI root ports. So this slide aims at giving you several representations of the PCI topology. So first of all, the UI part is virt manager, when you can see the different instances of PCI root ports. So those are the root ports. You have the root bus, and you can also see, in that case, a virt.io PCI device instantiated. Basically, this corresponds to this QEMU command line. So the matter is not to compare the size and so on, but just to show you that so it is basically the same. So if you use virsh, you will manipulate some XML files, and this is typically the XML representation of the PCI root port. But what is very important, what is very important to understand is that typically virsh will perform a kind of auto-completion. So typically you can just add in your virsh representation that you add the description of your virt.io PCI device, and virsh will automatically add the PCI root port for you. So typically in that case of the QEMU option line, you just take care of the virt.io PCI implementation in the XML description, and virsh auto-completes and adds the requested components in the PCI topology.
It's worth noting that the device hierarchy there, like the network interface, is PCI based, right? It's not with platform devices, or this is an enterprise server view, right? It's what you would expect.
Yeah. And by default, libvirt leaves a spare PCI root port to let you perform some hot plug and auto plug. Okay, so now we have a new feature that is available now in kernel 4.11, which is a PCI device assignment that comes along with full MSI support. So typically, if you want to install a guest, to provision a guest, and giving the PCI host device, you just add this option, so it's fairly easy. It's fairly easy to install such a guest, so it was tested. With virsh, You have several services. You can enumerate the PCI host devices that are candidate to the assignment. It provides you a kind of LS-PCI description. You are able to handle the binding between the device and the FIO PCI driver or native driver through the virch command line. But if you tell virch to manage this automatically for you, it will handle the binding for you. So to attach a device, you use the virch attach device command like that, and you provide just the PDF description of your host device. So it's quite practical. And obviously, the most practical way to do that is to use the UI tool, Virt Manager, where you add a simple window. You just select the PCI host device you want to add, and that's it. Okay, so another feature that is that can be exercised fully now, or nearly fully, is the migration of a guest that uses a GigV3 and an ITS, so the MSI controller that comes along with the GigV3. So now so you must use the kernel 4.11 for that, and the patch were pulled for 2.9 on QEMU side. And as for ITS migration, so patches are in flight, so we expect those to come soon. So as long as you have identical host systems, so you can easily migrate between them, you don't need the exact same QEMU version because we have a versioning at machine level. So here again, it is fairly easy. So this is the UI representation. So if you use Virt Manager, you can be connected to your remote nodes using an SSH connection. And you just select the node where you want to migrate, and that's it. So you have, of course, access to plenty of options because migration is quite intricate. So with virch, it's basically the same. So it's fairly easy to migrate. You select the URI, so the kind of URL of the source and destination, and you can perform live migration or offline migration. So both were tested using the different tools with the ITS and GigV3, so that works now. Okay, I am
back. Just a quick question. Sure. Quick question. Can you list the machine requirements for doing PCI pass-through? What does your hardware need to provide so you can do PCI pass-through?
You mean on host side or?
On the host side, yeah. Just because I think maybe the audio thing's great. Go do that on my Mustang, right? That might not work.
Okay, so for PCI pass-through, it is using VFIO, so you need system MMUs. So you have a mode where you can, the no IOMMU mode that can be used, but you don't have security. And so you need system MMUs. So typically you can use MD system, KM system, and so on.
Standard compliant.
Yeah. Does it answer your question?
You can do it V2.
Yes, actually, you
use drop isolation. Yeah, you don't have any drop isolation.
Yeah.
Okay, thanks.
Yeah, please.
There's enterprise in the title of your talk. In terms of SBSA and SBRR, at what level do you put the current virtual hardware?
High.
Do you want to?
Sorry, I didn't really understand the question.
If you had to describe the virtual hardware in terms of SBSA levels and SBRR levels, where is it currently?
I think we should follow up on that. But for MacBird, if I grab it, I think it would be, we're targeting the current level of, so level 2 is kind of the goal, I think, for where MacBird is going at this point.
I defer because I'm not a spec expert there.
We try to be as close to the SBSA as possible, but there are things that we can't do yet. Because, for example, SBSA specifies you should support EL2, right? But you're already using EL2 to run the hypervisor, so that would require nested virtualization. So there are things we can't do, and that's where the VM spec from the Naro comes in, that it tries to address exactly those differences but tries to lean as closely as possible against the SBSA and SBVR.
So as far as, like, UEFI and ACPI go, we are definitely aiming that. That's the main thing ADA supports, so that's working there, working.
Yep.
Since we have a really good quorum of people who have a good idea on how this stuff works in here, one thing that I haven't seen solved at all is router workarounds with ACPI on systems that have broken timers, for example, which happen to be out there. How do you populate that into guest? How do you make sure that with an ACPI system, you can say, I'm running on a host that has a broken timer and it needs to put that router back into the guest. Basically, the channel, which is the thing we're constantly struggling with ARM, that we're trying to design things in a really nice and clean fashion, and then hardware comes out, and obviously it's not ideal because it's hardware. They do the same mistakes that we as software people do, right? How do we get all? Do you have any solution to that yet? Do you have any plan on how to address hardware that currently just simply doesn't work that way?
Short answer hasn't really been considered, at least from my perspective for the machine.
That's not
We
entirely
considered
true.
it, yeah.
Yeah, that's not entirely true. So we actually did start looking at this a little bit. So is your question, when you create a VM on a machine that has an errata of some sort, how do you also tell it that it should also apply it?
Yes.
Because this stuff came up when discussing how do you support migration in a data center that has maybe slightly varying CPUs.
Yes.
So I sent an email a while back after KVM Forum last year, to the KVM ARM list at least, with some ideas that we should follow up on. It didn't get much traction, so we should try to circulate that more, and I think it requires involving a lot more people. But one idea could be to say, to tell the guest, here's the list of all possible errata that you ever possibly encounter, but we need the spec work, right? We need to figure out by ACPI, whichever mechanism you want.
We have worked it out. It's not
We need some sort of cross-platform repository of all possible errata and work out what's the possible combination of these, because you can have an errata on the platform, you work around it, you migrate the VM, then you land on a different platform.
Yep.
Where the previous workaround actually makes things even worse.
right.
So
Today we're assuming that's one of the reasons why we should shut up and let them finish. But that's one reason why every time it comes up, like not doing identical, homogeny to homogeny, where it's exactly the same host hardware, exactly the same revision, exactly the same router applied.
yes.
That's why I'm religious right now around saying that's all we can do today for that reason.
Even,
we do need to.
so even if we stick to that reasonable rule,
Yes.
Alex's point still stands.
Yes.
For example, with ACPI, we can't describe an erratum on the timers, for example. Such a case we have at the moment. Unless, for example, we fake the OEM ID to reflect those of the host.
Yeah.
And that's pretty dire, because that involves the whole stack, including queuing.
It's a follow-up. We should definitely follow up on it. We brought it up before. We should definitely. Yeah. It's nice that we have that problem now. We should fix it.
Very hard to fix.
Well, we should look at standardizing. I agree. But
And I think it's one of those where we do as good as we can.
yes.
Right?
Yeah,
And
I
we
mean,
You'll
can't
never
do
be
everything.
perfect,
Yeah.
but you can try.
Yeah, on the one hand, you don't want to standardize the solution for a router that makes it simple to run from beginning to finish. You know, so there has to be a bit of a
Thank you.
stick around it. And so that's why we've talked about router and CPI being fairly difficult to manage. We haven't like standardized the router type, so we can do something like that. And that has been, so that's the delicate balance.
Sorry, I think we'll have to, actually, this is a topic that's really interesting
Yeah,
too.
sorry.
We'll definitely want to talk about it later this week and everybody in a round table. Actually, I don't know how much time we have left. I'm afraid I wasn't timing like I should have been. And I see people coming in. Probably there's another session that started a long time ago. I have a few minutes. 5 minutes ago it started.
Well, you were already late before that. I mean, you didn't-
Let me just fly through in like
Yeah.
less than a minute or two, and then we'll be done. Okay, so the verification efforts going on in Red Hat. We use what's called Avocado. Avocado is a rewrite of Autotest that supports plugins. Now, I actually kind of wish that we had more time to talk about this, and I even wish that we had planned on talking about it more in the first place, because when I came to Connect. I see that verification, CI is a kind of a stronger theme, a bigger interest this time. And we could have maybe prepared a little bit more about it. I will say that for me, my preparation, I decided to grab Avocado VT. Avocado VT is the plugin that supports testing virtualization from libvirt down, the bits that we are interested in our team. And I was pretty happy with it. It wasn't exactly out of the box, push one button and everything worked, but it was pretty close. I was able to install new guests, boot them, migrate them, all pretty well. There are actually, I saw one of the things that was overwhelming when I grabbed the plugin was that there were thousands of tests there. Not all of them are applicable, I could tell by just doing some grumping on the names, but many of them are. And one of the great things about libvirt, to pump it again, was that those tests didn't really need much AR64 porting in order to be useful for moving them from where they were developed on x86 over to ARM. One other thing, you can run even other test suites if you just wrap them inside a pass-fail type of a test from Avocado VT. And the one that we find most interesting for the stack that we're testing is kvm-unit-tests for the lowest level. I'm quite interested in that. I tinker with it a lot. I won't go into it now. I do have one slide for it, but we can talk about that also at some other time. So, summary slide basically says what we already said, so we'll just go ahead and cut it. And thanks a lot, everybody.